Hi guys, uh, I am going to show you how to create a quick shifter for a Yamaha R3. Um, this is going to be an ignition delay quick shifter. What it means is that when the ECU on the motorcycle decides to ignite the cylinder, we're going to hold it down a little bit longer, delay it just enough so it fires when the piston's going down, causing the engine to lose power and allowing us to engage the next gear. So what we need to do is we need to learn to control the coil. This is the coil for a Yamaha R3. It has the spark plug right here. Spark plug is connected to ground through this cable. The coil itself has two connectors or two connections. One is the 12 volt power supply, and then it has this other connector that the ECU controls. The ECU connects this to ground for a fraction of a second, and then it disconnects it, creating a spark on this end. So we need to control this. So what we're gonna do is first let's see how this thing works. So a coil has a primary coil, and it has a secondary coil, and the spark plug would be here. This is where the spark is created. So the ECU controls this switch. So whenever it needs to fire, it'll connect it to ground, charges the coil, creates a magnetic field. When it's ready to fire, it disconnects it. The field collapses. This one converts or picks it up and um, steps up the voltage. For the Yamaha R3, I believe it goes up to 400 volts, and that's what creates the spark. The high voltage bridges the gap between the electrode and the ground. So what we need to do is we need to control this, create our own switch so we can control it, override the ECU, and fire whenever we want to. So how do we do this? We are going to do that with this switch. This is what is called an IGBT, uh, high voltage switch. This one can handle 600 volts at 20 amps. The coil itself has a resistance, I believe, is 1.6 ohms, which comes out to a roughly 6.6 amps that run through this primary coil, so more than enough to handle it. Now, the way the IGBT works, um, let me draw it here. It has three connectors. It has the gate, the uh, drain, and emitter. If it was a MOSFET, this would be the gate. Uh, I'm sorry, this is the collector. If it was a MOSFET, it would be a gate, drain, and source. So the way this works is this is how you control this switch through the gate. So whenever you apply voltage to the gate, this connector and this connector become, well, it connects this side of the connector to this one, creating a straight path to ground. So what we're going to do is we're going to connect the emitter to ground, and we're going to connect the collector to this part of the coil. So essentially, we are creating this little switch where by turning it on, it closes the switch, and turning it off, it opens the switch. So the way we control this is we need to apply high voltage to the gate. We have we're going to apply 12 volts, which is the maximum we have, um, just to make sure that it's fully open. So the way we do this is we connect the resistor, 10K resistor, and that will apply 12 volts to this connection, turning it on. So that would be the equivalent of closing the switch. Now, we need to be able to open the switch by removing the voltage or applying 0 volts to the gate, and that will open the switch and create the spark. We are going to control this through a processor, and this is going to be the tiny 85. This one runs at 5 volts, and obviously you cannot connect 12 volts to a 5 volt processor. It will destroy it. So what we need is we need an additional switch, and what we're going to use is we're going to use this little guy right here. This is an NPN transistor, and this is the 222A transistor. So this would be the front of the transistor. It has 3 legs as well. We have the emitter, the base, and the collector. And just like the IGBT, the emitter itself is connected to ground. We control the switch through the base. If we apply voltage and current, it connects the collector to the base, creating a straight path to ground. So what we're going to do is we're going to connect the collector to the gate. So when we turn on the switch, the NPN transistor, the voltage that is here will be driven straight to ground, leaving 0 volts. So essentially removing the voltage, turning it off. So what it's going to do is whenever we turn this on, this will be off, and vice versa. And to control this, we connect the base to the processor through a resistor, and this is going to be a 2K resistor. And whenever we apply 0 volts, it will be off. If we apply 5 volts, it will be on. So how do we tell the processor when to turn it on and when to turn it off? Well, for this one, it's going to be pretty simple. It's a simple, very small piece of code. What you do is on the main function, you are going to uh, uh, specify the pin that is going to control this. We're going to use pin 3 on port B. So what we do is, let's just call it, this is your main function. And in here, we are going to specify that pin B is going to be an output pin. So what we do is we go to the register for pin B, which is DD or B, and we're going to specify the DD B3 is going to be an output. Now, what we're going to do is we want to keep switching it on and off, so we just have a continuous continuous firing of the spark plug. So what we need to do is we need to to add a loop just to continue firing. So what we do is we're gonna this one, and inside this loop we're gonna start by turning the transistor on, so this one turns off. And the way we do that is we specify port B on pin 3 to be to turn it off. So port B, pin B3, and then we're gonna delay it for 100 microseconds, 1/10 of a second, and then we're gonna turn it off. So this turns on. Hold it down for um, for 2 milliseconds. So it's gonna be down for off for 100 milliseconds, then off for 2 milliseconds, and then it's gonna fire. So let's put a delay here in milliseconds. It's gonna be 100, and then we're gonna turn the transistor off so this turns on. And now the 2 millisecond delay, and we close the loop. And we close the main function. So what it's going to do is it'll set the register to an output, run through the loop, turn it on, wait 10 milliseconds, turn it off, 2 milliseconds, come back around and turn it back off, creating the spark. So it's going to be looping over and over. So the processor is going to be running at 8 megahertz. So we need to define the CPU variable so it knows it has the correct delay. So what we do is we define the F CPU, and we are going to have to add a library to have access to that delay function. And it's on the AVR delay.h. So that's it. That's the whole thing. So let's do that. Well, let's do it here. Here's my board. Here's my processor. This is the Tiny 85. It has the connections for me to program it. Now we need to. We're gonna start by connecting the transistor with the resistors, and then we're gonna connect the IGBT, and then test it with the spark plug. So what we need to do is we need to get a 2K resistor. Let's see. I believe this is my 2K resistor. Yeah. So this is my 2K resistor to pin 3. And we need to connect the emitter to ground. So it's going to be the pin right before that. Now we can connect the transistor. The flat part is facing me, so it's emitter base collector. Now for the IGBT, we need a 10K resistor. Do I have 10K? I don't know. Where's my 10K resistor? That's a 100K. Hold up. Oh, here it was. So we're gonna connect the 10K resistor to the gate. So there's a 10K, and we need to connect the. Uh, so we just sorry, this is wrong. We are connecting this to the gate, and then that's going to be connected to 12 volts right there. And then the emitter to ground. And here's we have the IGBT ready to go here. The silicon board. And if you remember, is the gate, drain, and source, or gate, collector, emitter. So that's how we're gonna connect it. And what do we need to do? We need to connect the coil. So for the coil, here's the coil. We are going to connect it to power. To ground. And to the collector. So if I power this on, nothing should happen other than it's just draining power because there's no control. So what we need to do is we need to add the code to that processor to be able to control the switch. So let's do that. So here's the code. All right, there we go. I'm going to start by defining the A CPU. That's 8 million or 8 megahertz. And we're going to include the AVR delay library. We have our main function already defined, so we just need to um, specify the pin that is going to be an output pin, DDRB, and we create our loop. What are we doing? We are turning it off. Would be, I'm sorry, turning it on. Pin B3. We are going to delay for 100 milliseconds. We are going to turn it off. And delay again for set 2 milliseconds. And that's it. That's this whole thing right here. All right, we send it. Done. So now when I plug it in, we should have spark. Let's see. So I don't know if you're gonna be able to see it. This thing just froze. Come on. All right. So let's see if we can get this. I don't know if you can see. Can you see a spark? Let's change the let's change the code a little bit so we can have spark a lot quicker. It'll be more visible. So what we are going to do is we're gonna delay it every 10 milliseconds. We're gonna fire. We're gonna hold it down for 3 milliseconds. Let's see. You send it. Okay, it's done. Let's connect it. This thing. Wait. Oops. Well, turn this off. So you should be able to see the spark a lot better now. You see it? There you go. So that's it. That's how you control an ignition coil. Now on the next video, I'm gonna show you how to detect the ECU when it's holding it down and when it's releasing it, so we can delay it. Right now we're just controlling this. We needed this so we can create the actual QuickShifter without having to plug into the motorcycle. So by having two coils, we should be able to test just like if we were connected to the motorcycle. So until next video, have fun.